What if our internet security didn't depend on complicated code that, can eventually be broken? What if, instead, it was guaranteed by the actual laws of the universe? Today, we're diving into a pretty wild idea, a completely unhackable global network built on the strange and frankly wonderful principles of quantum physics. And it's all happening in orbit, high above our heads. I mean, really think about that for a second. Your bank info, your private messages, your entire digital life. We wrap it all up in these layers of software encryption and we just kind of hope it's strong enough. But what if that whole foundation isn't as solid as we think it is? That question is exactly why scientists are looking for a totally new way to do things. And this right here is the key. Right now, our data travels through these glass cables crisscrossing the planet. And those cables have real weaknesses. You can tap them. Information can be intercepted. But the tech we're talking about today, well, it takes a completely different road, one that makes those vulnerabilities a thing of the past.
All right, so let's get into it. The internet we've built is an absolute marvel, no doubt. But its security has this one fundamental flaw. It's all based on software.
So check this out, because this slide really shows the massive shift we're talking about. On the left, you've got today's internet. Security is a software game. It's basically an endless arms race, right? We build more complex digital locks, and hackers, or maybe future quantum computers, work on building faster keys to pick them. But on the right, that's the future. An internet secured by physics itself. It's not about who has the faster computer anymore. It's about a system where snooping is, quite literally, physically impossible. So where does this crazy-sounding idea even come from? Well, it's not from a computer science lab. It's from the world of physics, specifically from the mind-bending world of quantum mechanics. This quote, it says it all, doesn't it? We're talking about moving away from creating locks that are just really, really hard to pick to creating locks where the very act of trying to pick them makes them self-destruct. The guarantee isn't written in code, it's written into the fabric of reality. Okay, so what's the secret ingredient for this brand new kind of security? It all boils down to this super weird quantum thing called entanglement. So let's break down how these so-called cosmic twins can create a perfect, unbreakable lock. So these entangled photons are basically the heroes of our story. Imagine you have two particles of light, photons, that are linked together forever, like a pair of cosmic twins. Now, if you check a property of one twin, like its orientation, you instantly know the state of the other one, even if it's thousands of miles away. But here's the crucial part. If anybody tries to peek at one of those twins to see what's going on, poof, the very act of observing it breaks that delicate quantum link. And that's the property we can use for security. So here's how it works in the real world. The process is called quantum key distribution, or QKD. First, you create a secret encryption key using these entangled particles. Then you send them where they need to go. Now here's the beautiful part. If a hacker tries to intercept one of those photons to read the key, the laws of physics kick in. The act of looking at it changes it. That change instantly breaks the link with its twin, and bam, both the sender and the receiver know their line's been compromised. The hack itself becomes the alarm bell. And this quote just nails it. This isn't some firewall that might have a bug or a password that can be cracked. The system is designed so that trying to intercept it literally violates the laws of physics. It makes it impossible to listen in without getting caught. The security is just a basic property of the communication itself. So this quantum security stuff is incredible, right? But how do you actually make it work on a global scale? Sending these super fragile quantum signals through thousands of miles of fiber optic cable on the ground is almost impossible. The signal just falls apart. So scientists are looking up. They're going to space to build this network. Okay, so the very first step before a single quantum key can be sent is to get a whole network of satellites, these orbital nodes, all perfectly in sync with each other. You got to think of it like a celestial orchestra where every single instrument has to play in perfect time. That synchronization, that's the foundation for the entire system. And once they're all synchronized, that's when the real magic happens. These satellites start beaming those entangled photons to each other across the vacuum of space. And it turns out that near-perfect vacuum is a much, much cleaner place for these fragile signals than our atmosphere or a glass cable. It lets them create secure links over thousands of kilometers. So you link all these satellites together, and what do you get? You get a secure data-sharing backbone that stretches across the entire planet. Your information can hop from one satellite to another, and its security is guaranteed every single step of the way by the laws of physics. You've created a truly global and truly tamper-proof network. So what does all this add up to? Well, it's the promise of a future where our digital lives can finally have a level of security we've only ever dreamed of. We're talking absolute security. And this is the end goal, a tamper-proof global backbone, an internet where you don't have to add on security stuff like firewalls or antivirus software after the fact. In this new world, security is a fundamental, unchangeable property of the network itself. It's built in from the ground up, and it's guaranteed by the universe. Just let this number sink in for a minute. 100%. In our digital world today, security is really just a game of probability. But in a quantum network, it's a game of certainty. If someone tries to listen in, they will be detected. Every single time. There's just no such thing as a stealthy interception. And that kind of leaves us with a fascinating last thought. Just imagine a world where your financial transactions, government secrets, your personal messages, everything is protected with that level of certainty. It would completely change how we interact with the digital world. So what does that future with truly absolute privacy actually look like? That's definitely something to think about.